Hello everyone, I welcome you all for a brief video presentation on the topic Probability Theorem of Engineering Mathematics 3rd semester. My name is Bharath. I belong to 3rd semester Computer Science Engineering and Artificial Intelligence Department. The subject which I am going to handle is Mathematics for CSE stream 3rd for 3rd sem. The course code is BCS 301. This is about the theorem of probability. What is probability? Probability is a branch of mathematics that deals with the likelihood of events occurring. Um, it is used to quantify uncertainty and make predictions based on data and assumptions. What the basic concepts are: sample space, the set of all possible outcomes of an experiment is called as a sample space. Event is a subset of the sample space. Probability of an event, the likelihood of an event occurring expressed as a number between 0 and 1. These are the basic concepts. What is probability? Probability is a branch of mathematics that deals with the likelihood of events occurring. It is used to quantify uncertainty and make predictions based on data and assumptions. So this was about the introduction to the probability theorem. Let us now look at the next slide. The principles of probability: addition rule and multiplication rule. The probability of the union of two events is equal to the sum of their individual probabilities. This is the addition rule. Multiplication rule states that the probability of the intersection of two independent events is equal to the product of their individual probabilities. Applications: probability theory is used in various fields including statistics, finance, engineering, and computer science. It is used to analyze and predict outcomes in games of chance, weather forecasting, risk assessment, and quality control. Probability theory is used in various fields including statistics, finance, engineering, and computer science. It is used to analyze and predict outcomes in games of chance, weather forecasting, risk assessment, and quality control. This is the application of probability theorem. The probability of union of two equal events is equal to sum of their individual probability. Probability of intersection of two independent events is equal to the product of their individual probabilities. Basic concepts of probability: sample space. The sample space is a set of all possible outcomes of an experiment. This sample space is denoted by S. And for example, when flipping a coin, the sample space is heads or tails. An event is a subset of the sample space. It represents a specific outcome or a combination of outcomes. For example, in a coin flipping experiment, the event of getting heads is denoted by E equals heads. Probability calculations. The probability of an event E, denoted by P of E, is a measure of the likelihood of that event occurring. It is calculated as the ratio of number of favorable outcomes to the total number of possible outcomes. The probability of an event ranges from 0, which is impossible, to 1, which is certain. This is the sample space, which is a set of all possible outcomes of an experiment and denoted by S. Probability distribution describe how likely different outcomes are in a random phenomenon. They can be discrete, like a coin flip, heads or tails modeled by the Bernoulli distribution, or continuous, like the height of people described by the normal distribution. The shape of a distribution is determined by its mean, which is average, and variance, which is spread. Common distributions include the uniform, binomial, Poisson, exponential, and gamma distributions. Probability distributions are fundamental in statistics and are used to model and analyze data in various fields, helping us understand the likelihood of different events and make informed decisions. Common distributions include the uniform, binomial, Poisson, exponential, and gamma distribution. Probability distributions are fundamental in statistics and are used to model and analyze data in various fields, helping us understand the likelihood of different events and make informed decisions. Discrete probability distributions, Bernoulli's distribution, binomial distribution, and Poisson distribution are the three important ones. Description is Bernoulli's distribution models a single experiment with two possible outcomes, that is success or failure. For example, which is a coin toss. Binomial distribution is described as models a sequence of independent Bernoulli trials with a fixed number of trials and a constant probability of success. Number of heads in multiple coin tosses is an example of binomial distribution. Poisson distribution models the number of events that occur in a fixed interval of time or space, given the average rate of occurrence. Number of phone calls received in an hour is the Poisson distribution, models the number of events that occur in a fixed interval of time or space, given the average rate of occurrence. Number of phone calls received in an hour. This is Poisson's distribution. Number of heads in multiple coin tosses is an example of binomial distribution, and coin toss is an example of Bernoulli's distribution. Next, continuous probability distribution, which is rolling a fair six-sided die. Uniform distribution is normal distribution, and exponential distribution are three types of distributions. Uniform distribution models events that have an equal probability of occurring within a specified interval. Example, rolling a fair six-sided die. Normal distribution models a continuous random variable with a symmetric bell-shaped curve. It is widely used due to the central limit theorem, which is the height of individuals in a population. Exponential distribution is models the time between events occurring in a Poisson process. It is often used to model waiting times. And let us look at some of the examples. Rolling a fair six-sided die, uniform distribution. Height of individuals in a population, normal distribution. Time between customer arrivals at a store is an example of exponential distribution. Next slide is conditional probability. Conditional probability is the probability of an event occurring given that another event has already occurred. It is denoted by P of A or B and is calculated as the probability of both events happening divided by the probability of the conditioning event. For example, if we want to find the probability of drawing a red card from a deck of cards given that we know the card drawn is a face card, we would calculate it as the probability of drawing a red face card divided by the probability of drawing a face card. Conditional probability is essential in Bayesian statistics, machine learning, and various applications involving uncertainty and dependent events. Conditional probability is the probability of an event occurring given that another event has already occurred, denoted by P of A or B, and is calculated as the probability of both events happening divided by the probability of the conditioning event. This is about the conditional probability. In the next slide, we'll look at the applications of conditional probability. Conditional probability is widely used in probability theory and has various applications including Bayesian inference, which is conditional probability is key concept in Bayesian inference, which is used to update beliefs or make predictions based on new evidence. Medical diagnosis is the conditional probability is used in medical diagnosis to calculate the probability of disease given certain symptoms or test results. Weather forecasting is a conditional probability used in weather forecasting to estimate the probability of a certain weather condition given current weather data. Risk assessment conditional probability is used in risk assessment to calculate the probability of a specific outcome given certain conditions or factors. Quality control. Conditional probability is used in quality control to assess the probability of a product being defective, given certain test results or measurements. These are the applications of conditional probability. Next, let us move on to the next slide, which is the Bayes theorem. Bayes theorem describes the probability of an event based on prior knowledge of conditions that might be related to the event. It is named after Thomas Bayes. Mathematically, it is stated as P of A or B is P of A into P of B or A into P of A, where P of A or B is the probability of event A occurring given that B is true. P of B or A is the probability of event B occurring given that A is true. P of A and P of B are the probabilities of A and B occurring independently. Bayes' theorem is fundamental in Bayesian statistics, machine learning, and various fields for updating probabilities based on new evidence or information. This is about the Bayes' theorem. This is P of A or B, P of B, P of B or A into P of A. This is about the Bayes' theorem. What is the significance of Bayes' theorem? We'll look into it. Bayes' theorem is significant because it provides a formal way to update the probability of a hypothesis as a new evidence or information becomes available. This makes it a foundational concept in Bayesian statistics and machine learning, where it is used for decision making, hypothesis testing, and modeling uncertainty. Bayes' theorem also plays a crucial role in fields like artificial intelligence, medical diagnosis, and finance, where decisions often need to be made under uncertainty and with complete information. Its ability to incorporate prior knowledge and update beliefs based on the new data makes it a powerful tool for reasoning and inference. Bayes' theorem is significant because it provides a formal way to update the probability of a hypothesis as new evidence or information becomes available. This makes it a foundational concept in Bayesian statistics and machine learning, where it is used for decision making, hypothesis testing, and modeling uncertainty. This is the significance of the Bayes' theorem. Now let us move on to the next slide, which is random variables. A random variable is the variable whose possible values are numerical outcomes of a random phenomenon. It assigns a numerical value to each possible outcome of a random experiment, and its value is determined by the outcome of that experiment. Random variables can be classified as either discrete or continuous. Discrete random variables take on a countable number of distinct values such as number of heads in series of coin flips. Continuous random variables, on the other hand, can take on any value within a given range such as the height of a person. Random variables are fundamental in probability theory and statistics, serving as a way to quantify and analyze certain outcomes in a wide range of applications. This is about the random variables. Discrete random variables are variables that can take on a countable number of distinct values. Each values are typically the result of counting, such as the number of heads in a series of coin flips or number of cars passing through a toll booth in an hour. The probability distribution of a discrete random variable specifies the probability of each possible value that the random variable can make. This distribution can be described using the probability mass function, which gives the probability of each value. The sum of the probabilities for all possible values of a discrete random variable is always equal to 1. Discrete random variables are used in various fields, including statistics, finance, and engineering, to model and analyze situations where outcomes and distincts are countable. Now let us look at what is a continuous random variable. Continuous random variables can take on any value within a range. Examples include height, weight, and time. They are described by a probability density function PDF, which gives the likelihood of the variable falling within a specific interval. Unlike discrete random variables, which have a countable number of values, continuous random variables have an uncountably infinite number of possible values. They are used in various fields to model and analyze phenomena where outcomes are not limited to distinct values. This is about a continuous random variable. Expected value and variance. These two are different experiences, and the expected value of random variable is a measure of its central tendency or average value. It represents the long-term average outcome of a random experiment. Variance of a random variable measures the spread or dispersion of its possible values. It quantifies how much the values of the random variable deviate from their expected value. And before finishing, we'll see what is the importance of probability theory. This is risk assessment, financial modeling, quality control, statistical inference, and hypothesis testing. These are some of the importance of probability theory in real life application. So we have come here. Thank you very much for your attention. We have explored fascinating concepts in mathematics, from probability distributions to calculus. We have seen how maths shape our world. Let's continue to explore its wonders together. Thank you very much for your presence. See you soon in the next video. Thank you very much.